Hello, in this video we will take a look at mathematical induction. Essentially what mathematical induction is a particular technique of mathematical proof. And we use induction when we want to prove that a certain statement Pn is true for any natural number where n could be 0, 1, 2, 3, etc. So it is often compared to domino effects. That's why you see those little dominoes in the title, because essentially you prove that the first domino falls and that if it falls, it topples the second domino. So if you prove that there's this connection between the first and the second domino piece, that means that all of them topple, and that proves that the statement holds for any natural number. So the steps for this, the particular steps, would be pretty easy, I would say. It's nothing too fancy or too complicated. You start by looking at your basis. So you take n equals, let's say 1. It could be 0 or it could be 1. You have to prove either. So you plug it in, you calculate the result, and you see if it's true. And if it is, then you continue and you assume that the statement is true for a certain number k, which could be any natural number, right? And you assume that it's true for k, then it has to be, you have to show that it's true for k plus 1. So k is your first domino, and then k plus 1 is your second domino. You have to prove that the first domino topples the second one. Now, it all might sound a little bit confusing and complicated in theory. However, when we get to practice, you're going to see that it's much more straightforward. So let's go ahead and try to prove a pretty simple statement. So we have to prove that see the sum of any number up to including n equals to this formula here. And we'll start by having our basis checked. And so let's say first n equals 1. And let's see. So on the left-hand side, it's just going to be 1. And on the right-hand side, we have 1 times 2 divided by 2, and that equals to 1, which is our left-hand side. So, all right, that proves our basis. Now let's move on to the second step. And the second step, we assume that n equals k, and that the statement holds true for k. Now, lastly, the third step, and this is the creative part of it really, is we have to show that the statement, now let's write here first, assume true, n equals k plus 1 has to be true as well. Now, how do we do that? First, let's write our k statement on the right hand side. So we have k times k plus 1 divided by 2. So what we have to show is that this statement plus k plus 1 equals to the right-hand side statement for k plus 1, which is k plus 1 times k plus 1 over 2. So let's just expand our first part, the left-hand side here. Let's see if I can, it's glued together. All right, never mind. And what is it going to look like? So we can clearly factor out k plus 1, but first we need to find the, make sure there's a common denominator, and it will look like this: k plus 1 plus 2 times k plus 1. Look at that. So this example, I gotta admit, it's quite simple. There's going to be a homework problem right up next, and it's going to be a little more challenging, but I'm sure you're up for a challenge. Nevertheless, let's factor out our k plus 1, and that just leaves us, of course, with k plus 2, and all of that is divided by 2. So what did we just get? We actually got our statement for k plus 1 by simplifying, by adding k and k plus 1. So in case you're confused, look, we have this sequence here, 1 plus 2 plus 3, and then we could say that instead of n, let me erase that. So, ta-da-da-da-da. Okay. Plus 3, plus k plus 1. So you see, all we did is we took k and we actually substituted k for this thing here, which is the formula that we're trying to prove. And then we added the next term, k plus 1, to it. So, and that turned out to be the same as this equation when you plug in k plus 1 into it, right? And that's basically how mathematical induction works. And for your homework, I want you to prove this statement, so that the sum of squares of integers from 1 to n equals to this formula here. Good luck with that, and we'll make a follow-up video where I go through this problem, and in case you want to, verify your solution, I'll see you there. Thank you for watching. Don't forget to like and subscribe, and stay tuned for more math videos.